So this lesson is all about pendulum, which is simple harmonic motion as well. So look at what's going on here for the pendulum. A mass, an object which has mass m. So I'm just gonna write down as this is h, 10 kilograms. It's actually attached to the rope that is attached to the ceiling that has a length of 10 meters. So now this is at the lowest point. So the object itself is actually being raised up to a certain point, which has the h equal to 5 meters. This is the questions, okay. So go ahead and answer for question number 1. An object attached to the pendulum will have how much potential energy. So this lesson goes back to three different types of energy that we actually understand. First is the potential energy. Second, which is the potential energy due to the spring constant. And the third one, which is kinetic energy. So let's go ahead and write it down. Potential energy is equal to mgh. So I'm just going to go ahead and replace the mass with 10 kilograms, gravity 9.8, and the height is 5. So your potential energy will be equal to, basically roughly, so instead of using 9.8, I'm just going to go ahead and make it as 10. So that would be around 500 joules. That's what it is for potential energy. So now look back here. So what happened when pendulum is actually being released and when it goes to the lowest point in time? So now the pendulum is right here. So what would happen to its kinetic energy? So go ahead. Kinetic energy is equal to 1/2 mv squared. And also, with this being the case, since the energy is not lost, so it has to be equal to mgh. So whatever the answer that you have from here, that will be your kinetic energy as well. So question number 3, how fast will this object be at the lowest point? So with this, you're gonna have to utilize the concept of, so right here, which is potential energy is equal to kinetic energy. So potential energy is mgh. This is 1/2 m velocity squared. So in order for you to figure out how fast, which means it is v, you're going to have to figure out how to rearrange the equation to solve for velocity. So I'm going to go ahead and do 2gh. I'm getting rid of 2, I multiply both sides of the equation by 2. That get rid of that. And I do square root, and that will be it. And that is your final velocity when you have to figure out what it is. So this one, you're going to have to figure out how long it takes for a pendulum to complete one cycle. So let's go back, to this graph again. This is time, this is velocity versus time graph. So over here, at the highest point or at the very beginning, or its initial state has no velocity. That's why I'm going to go ahead and put it right here. And it goes here, it gains speed, and finally it goes right here to where it is on the other side. Same height, it drops. And now it swings backwards. Go here. All the way to complete one cycle to where it actually came from here. This is what happened. It is initial and final should be the same position. So now if it only takes 4 or 2 seconds from here to here, so which means this one itself is actually take 2 seconds, right? So you were asked to figure out how long will the pendulum actually finish or reaches its cycle. So you're gonna have to do 2 times 2 times 2 times 2. I'm sorry, you actually add it up. So either way, if you wanna do it this way, you can do 2 times Actually 4 times. It's this one, that one, that one. So 2 times 4 is equal to 8 seconds. Or you will do the same thing. Just add up all these seconds. 2 seconds, 2 seconds, 2 seconds. And at the end, the answer should be confirming with 8 seconds as well. So that's how you would solve for this type of problem. So the lesson is all about pendulum. It's all about how you will figure out how to determine the period. But this one is not from the equation, but it's from the interpretation of the graph, or actually looks at what's happening. So 1, 2, 3, question 1, 2, 3 are actually the review of the old material that we've done for the first semester. But for this one, it's all pendulum. But you will use the same concept. Hope this helped.